everyone and welcome back to the new video of this channel. So today we will be solving a problem which is add one row to tree. LeetCode 623 problem. So let's see the problem is here. So problem is saying that we have given a root of a binary tree and the two integers value and the depth. They add a row of nodes with value at the given depth. Okay, so note that the root node is the depth 1. Okay, root node the depth is 1. The adding rule is there are some rules like given the integer depth for each null tree node current. Like let's directly see the example because it will be confusing for you to see the rules. Let's directly see the example. We have given the root array, we can see, because we can say the tree 4 2 6 3 1 5. These are the elements in the tree and value is 1 and depth is 2. It means we have to add the value at the depth 2. Like here is the depth 1, this is the depth 1 and this is the depth 2. We have to remove these two nodes and we have to add 1 except of these nodes. Like if we add ones like 4 then 1 1, then we have to add these nodes, remaining nodes 2 6 then 3 1 5, like this. Let's directly see the another example like 4 2 3 1 4 2 3 1 and this is a null pointer. Okay, so we have given a value 1 and depth equals to 3. Depth equals to 3, it means like this is the depth 1, this is depth 2, this is depth 3. We have to remove these nodes and we have to add the value except of these nodes. So if we add these values, so like my tree will be like 4 2, then we will remove these two nodes and we'll add one except these nodes, so 1 1 will be there. Then again we will add the remaining nodes are 3 and 1, so 3 and 1 we will add. So now let's directly see the approach part for this. So approach part is very simple. What we will do is, if my depth value is 1 and depth equals to 2, depth equals to 2, it means this is the depth 1 and this is the depth 2. So what we will do, we will remove these two nodes and we will add the values except of these nodes. So what we will do is, we'll keep track of left pointer or right pointer. So root का left equals to left temp. I am telling it like left temp, and the root का right equals to right temp. Right temp is showing 6 value 6 and left temp is showing the value 2. So now what we will do, we will remove these two nodes and we will add the value except of these nodes. So now रूट का लेफ्ट इक्वल टू न्यू नोड ऑफ वैल्यू. मैं एक रूट का लेफ्ट बना रहा हूँ जो एक न्यू नोड है जिसकी मैं वैल्यू पड़ी हुई है, वैल्यू इज 1 हियर, एंड रूट का राइट इक्वल टू न्यू नोड ऑफ वैल्यू. इट मींस वी आर एडिंग, रूट का लेफ्ट में कौन सा ऐड वैल्यू को ऐड कर रहे हैं और रूट के राइट में नई वैल्यू को ऐड कर रहे हैं. सो वी आर एडिंग द वैल्यूज अकॉर्डिंग टू द रूट का लेफ्ट एंड रूट का राइट. एंड नाउ व्हाट वी विल डू, we have to add these values like root ka left temp value and the right temp value. So how we'll add, so we'll simply add these values like root ka left. In previous, root ka left equals to 2 and root ka right equals to 6. Now root ka left equals to 2 and root ka right equals to 6. So simply we will write here like root ka left equals to left temp value is showing the value 2, which I have stored here. Root का left equals to left temp, which is showing the value 2, and also root का right equals to right temp, which is showing the value 6, which I have stored here. Root का right equals to right temp. So now finally we will return it and simply do the function call. So it's a recursion technique. So now let's directly see the code for this. So coding part is very simple. Like if we will write a condition like if my depth is equals to 1. If my depth is equals to 1, it means we have to remove that node. This because this is my depth 1. So we have to remove this node. So what we will do is we'll create a new node, new root value, because we have to remove this and we will add some value here, and again we will attach the remaining nodes through this. So what we will do, we will create a new root which contains a value. Value is like if example is here depth equals to 1. If let's say depth equals to 1 and value equals to 1, so 4 के को हटा के क्या कर देते, 1 ऐड कर देते, देन इस पूरे को ट्री को कॉपी कर देते. So in that case what we will do, we will simply create a new node, new root value, which value is equals to value, and न्यू रूट के लेफ्ट क्या हो जाता, रूट हो जाता, और फाइनली रिटर्न कर देते न्यू रूट को. एंड नाउ व्हाट वी विल डू, we'll simply create a function which name is add, and we will pass some values like root value, depth, and 1. 1 is showing the current value, current depth. So now let's see the function. Now we'll write a condition. This is the base condition for this. If my root equals to null, so simply we will return null. Now we'll check like if my current equals to depth minus 1. If I am at the previous, like here depth equals to 2, so I am here depth equals to 1. Now what we'll do, we'll simply store left temp, so root का left and root का right in left temp and right temp. So tree node star left temp equals to root का left and tree node star right temp equals to root का right. These values are showing like 2 and 6. Root left temp is showing 2 and right temp is showing 6 here. And finally, after creating the final tree, what we'll do, we can see here कि root का left equals to 2 and root का right equals to 6. It means we have shift हो रहे values, so that's why we have created left temp and right temp here. And root का left equals to new tree node of value को उसमें root के left में डाल रहे हैं और root के right में भी value को डाल रहे हैं. Now रूट के लेफ्ट को लेफ्ट टेम्प के इक्वल कर देंगे, बिकॉज यू कैन सी हियर नाउ माई 2 इज रूट का लेफ्ट एंड 6 इज रूट का राइट का राइट. सो दैट्स वाई रूट का लेफ्ट इक्वल टू लेफ्ट टेम्प and root का right equals to right temp here. And finally we will return the root. And after this we will simply do the function call like root का left equals to left की function call and current को +1 कर देंगे because depth will increase. So and again root का right equals to right की function call value depth and current, the current depth or current position of the depth, and it will increase by 1. That's why. And finally we will return root. So now let's run this and see if this will work out. You can see it is working perfect. Let's submit this code. Yes, it is taking 18 millisecond time. That is a good approach for this. And here what we are doing is we are just using the recursion technique and we are writing some conditions here. If my depth equals to 1, then we will do simply this condition, and finally we will write a function. And in function, firstly we will write a base case. If my root equals to null, then we will simply return null, and we will write this condition like if my current value equals to depth minus 1, then we will do something else. And finally we'll make a function call for left and right, and the depth will increase by 1 also. So this was the code. If you find this helpful, then please like, share, and subscribe. Bye.